All right, welcome back to the next video in our series in distance learning. So we are going to start a new section today. These things called conic sections. There's 4 conic sections that we're going to talk about. The first one we're going to talk about is parabolas. And then as we kind of continue to move forward, we'll also talk about ellipses and hyperbolas and circles, which circles are kind of a special case of ellipses. So we'll kind of be doing those in the next few weeks. Today's video is going to be primarily about just graphing parabolas, which you've done before, but we're going to get into a little more detail about some of the different attributes that you did talk about briefly in Algebra II, but we're going to get kind of really into specifically how to find the focus, the directrix, and what's called the latus, rectum, endpoints. Okay. As I go through this video, it's really a good idea to have a piece of paper and pencil to take a few notes down. I'm going to have a couple slides where I'm going to kind of have all the different kind of attributes there at once. And then there's some opportunities to graph a couple of them on your own and stuff like that. Okay, so if you need to pause the video and get some paper and pencil, that'd be a great idea. So let's review a couple of things from Algebra 1, right? So we know what a parabola looks like, and some of these words might sound familiar, they may not, but remember, for sure, you should definitely remember that a parabola definitely has a vertex. For most of the ones you talk about in Algebra 2, they're either a minimum or a maximum point. So you see where the vertex is right here. But they also have a couple different things going on too. They have this thing called a focus point, and they also have a line that's outside of the parabola that we call the directrix. Now what happens is when we look at the actual technical definition of a parabola, every point along the curve is equidistant from the focus and the directrix. So if you pick any kind of random point up here and you measure the distance from here to here and the distance from here down to the directrix, it's going to be the same. Now, in full disclosure, I know it doesn't look like it's the same on my graph right here because my scale, notice my y-axis scale is by 1s and my x-axis scale is by 2s. That's why it doesn't look the same, but I promise it is the same distance from both of those things. So we're going to find out how to find where that focus point is and where that line that's called the directrix is. And then we're also going to look at these things, which you didn't cover in Algebra 2. These are called the endpoints of the latus rectum. Now, the latus rectum is a Latin term called straight side. So we're going to talk about how to find those also. Okay, so that was for an upward-facing parabola. Remember, in the conic section land, we can also talk about parabolas that go right or left, and they have the exact same properties. So we have a vertex, focus, directrix, and the latus rectum endpoints. Excuse me. Okay, so primarily what we're going to be talking about is very similar to what you saw in Algebra 2 called vertex form. And if you remember from vertex form, that equation looked like this. So y equals a parentheses x minus h squared plus k. Now, back last year, we called a like a vertical stretch, horizontal stretch. We're really not going to do that in this case. We're going to use a for something else. It's going to help find these different points. Now, for right left, it's basically the same format. Notice the xy's also switch, but the h and k also kind of switch places. Okay, so on both of these forms, remember hk is the vertex, but guys, it's super important that you realize that depending on where it is, you know, which letter is by itself, whether it's the y or the x, hk is the vertex. But again, there are different places depending on which parabola you have, whether it's up, down, or right or left. Okay. Now, what we can say for sure on all of these things is that if a is greater than 0, in other words, if it's positive, it's either going to open up or to the right. And if a is less than 0, a is negative, then it's going to be opening either down or to the left, depending on which formula you have there. Okay. And again, I said this a second ago, But we're not going to call these vertical stretches or compressions. We should know what those are, of course. But we're going to talk about other attributes that's going to let us graph these things and get the real shape of this thing. Okay. So I'm going to throw some formulas at you and kind of just using these different letters. But then we're going to get into the examples, and I'll give you an opportunity to do one or two of them by yourself. Okay. So the first thing we have to find is we have to find this thing we call the p-value. Okay, now this is a straight up formula, and it doesn't matter if it's opening left, right, up, down at all. What the p-value is going to do, though, is it's going to give us the distance from the vertex to both the focus and the directrix. Okay, so it's just a distance value. The way we find that is p is equal to 1/4a. That's it. Okay, now in full disclosure, a lot of times a might be a fraction itself. So we have the fraction side of a fraction, but you should be okay with doing that by now. Okay. Two points to remember also. The focus is a point, and it's always going to be inside of the parabola. So whatever direction you see that it's going, if it's up or down or whatever, the focus is always going to be inside of that curve. And the directrix is a line, and it's going to be always outside of the parabola. Okay, so important things to remember, and if you kind of follow along with how to use the p-value to find those spots, it almost graphs itself, and you'll see what I mean by that in a few minutes. So how do we find the focus and directrix? Okay, using that p-value. And notice I put both formats over here on the right, and I put the p-value formula. It's a good idea to write those down in your own paper, but I'm going to have those there for a while. Okay. So remember, our vertex is HK. Important to remember that because that's kind of the basis of this whole thing. For up-down parabolas, our focus, remember, we know it's going to be inside, right? So the focus is going to be wherever the vertex is, and we're going to add that p-value to the y value of the vertex, okay? Okay. Now notice that plus sign. There's always going to be adding. P could be negative, which would mean it would be going down, right? So, but it's always going to be adding to the y value, those up-down parabolas. And then for the directrix, remember, it's in that opposite direction. So you're going to take the k value and subtract the p. Okay. So what's that going to look like? It's always going to be a horizontal line. Okay, and it's going to look like this. And so here's basically the same picture I showed you a minute ago, but I got the p-values in here. So notice, here's your vertex. If I add that p to the y value, you see it going up. If I subtract the same p-value, I'm going down. Now, if p was negative, again, the whole thing would be upside down. So the parabola would be going down, the focus would be going down, and the directrix would be on top of the parabola. Okay? How about for right-left parabolas? Well, it works the exact same way, but this time the focus is going to be going to the right or left of the vertex. So again, we're going to take that p-value, always add it to the x value of the vertex. And then for the directrix, we're going to subtract it from the x value of the vertex. Now remember, the directrix in this case is a vertical line, right? So now my picture is going to look like this. So this is for a right hand, so again, p would be positive. So I'm going to add the p, subtract the p, and you kind of go from there, okay? Now, the one thing I'll say, and I kind of alluded to this, that, man, you got to watch your signs here, because if A is positive, that means P is going to be positive, so it'll be either going up or to the right. But if A is negative, then P is negative, and then your parabola should be going either down or to the left. Okay, so, but these little formulas here, those formulas will never ever change. You're always going to be adding for the focus and subtracting for the directrix. It's just going to be depending on what the sign of P is. Okay? Last two things we got to find are the endpoints of the latus rectum. Okay? The way, and again, these are the other points. These are kind of where your vertical stretch or whatever, that's where these kind of come into. That's how we're going to define the shape. It's always located 2p. Notice 2 times p. And they're located that distance away from the focus. So we have our vertex, then we find our focus, and then our latus rectum endpoints are going to be 2p away from the focus. For the up-down, we take this focus point, which again was this h comma k plus p, and we're going to add and subtract that 2p left and right. Okay, so that latus rectum is going to be horizontal, left and right, 2p units from focus. Okay, and that's what that looks like. I kind of took away some of the other labels here, but here's your 2p units. Okay, and notice we see p here is 2, 2p is 4, and sure enough, that's my 4 units away. Okay. And then for the right-left parabolas, again, we take whatever the focus is, and then we're going to go up and down 2p units to find those, and that's what that will look like for a right-handed parabola. Okay, so again, my p is 2 here, my 2p would be 4, so up and down 4 from the focus, and then that's kind of what defines the shape. Okay, same thing, watch your signs. Particularly when you find the focus, because again, for the latus rectum endpoints, you're going to be going both directions anyway, so it's so that's not going to be too bad. Okay. So I'm going to give you an opportunity real quick to pause this screen because here's everything. Here's everything that you need to be able to find attributes and graph parabolas. Vertex. So there's the 2 different forms of the equations. The vertex, focus, directrix, and the latus rectum endpoints. I know you're looking at that going H, K's, P's everywhere and stuff like that, but I promise once we do go through a couple of examples, it'll make a lot more sense. Okay, so hopefully you've got those written down and kind of be able to refer to them, because I'm not going to have these formulas out when I do the examples, but let's go ahead and jump in and do one of these. So here's my first equation, y equals 1/8 times x minus 3 squared minus 1. And I've got a grid over here. You may not have graph paper right in front of you, and that's okay. Just draw an x-y axis and kind of, just do normal lines, 1, 2, 3 on the x-axis and y-axis. All we're looking for is a sketch, okay? So the first thing when I see this, I'm going to go and write the vertex. Now, I see that it's y equals, so that tells me it's going to be going up and down, right? And I see that my a here is positive. So I know right off the bat that this is going to be an upward facing parabola, okay? So I'm going to write my vertex down first. And my vertex is h and k. Remember, it's kind of the normal way. So but remember, anything inside the parentheses, always the sign gets changed. So my vertex is going to be at 3, -1. So I'm going to go and plot that point over here. There's my 3, -1. Now the next thing I can do is find my p-value. And I put that formula up here just for reference. So this is going to be 1 over 4 times 1/8, because that's my a value. You multiply that out, that's 1 over 1/2. Do the keep change flip thing. So my p-value is +2. Okay, and now I just find my different values. So for my focus, I take my vertex, and again, I know it's going to be going up, right? So I'm going to take my x value is not going to change, and I'm going to add 2 to the y value of the vertex. So -1 + 2 is 1. So my focus is going to be at 3, 1, which would be right here. Okay, so that's my focus point. Good. Now for my directrix, I'm going to take this, I'm going to go back to my vertex here, and I'm going to go the opposite direction, guys. Instead of going up 2, I'm going to go down 2. Okay, so my y value here is at -1. If I go down 2 more, I'm at -3. So y equals -3, and that's going to be that line right there. Okay. And then my other last things I got to find are the endpoints of the lattice rectum, which I'm going to abbreviate LR. Okay. And again, remember, we go to our focus now. We're done with the vertex. Now we go to our focus, and we're going to go left and right 2 times p. So my p was 2. 2 times 2 is 4. So I'm going to go left 4 and right 4. Okay, and mathematically, that's just that. So 2 times 2 is 4. So 3 plus 4 is 7. 3 minus 4 is -1. So those are my 2 points right there. And then I'm just going to connect those points because my parabola kind of goes through the lattice rectum vertex, other lattice rectum endpoint, and kind of go on from there. Now, clearly, the parabola would keep on going forever. I don't have a touchpad laptop, so I had to do this kind of by hand, and that's kind of the best I could do with that. But that's good enough, and that's our good representation of what the parabola. Okay. Let's go ahead and do one that goes left to right here and see what that looks like. So here's the next one, and so now we have x equals all this stuff, and you see don't forget the negative sign out front here. Okay, so again, the first thing you got to do is find the vertex. I know it's x equals, so it's going to go right or left. I know a is negative, so that means it's going to the left. Okay, but the main thing with the vertex, again, remember here, this is my h here. So my h is a 6, but my k would be +2 because anything inside gets changed. Okay, so my vertex is going to be at 6 +2, which will be over there. So I'm going to find my p-value, same formula. Again, it's still going to be negative. Plug that in. So 1 over -1/3 would be -3. Okay. And again, now I know it's going left and right. So I'm just going to add, I'm going to go to my vertex, and I'm going to add a -3. So 1, which means I'm going to the left 3. 1, 2, 3. So my focus, if I go left 3, I'm at 3, 2. And remember, for the directrix, I'm going the opposite direction. So I go back to my vertex, go 1, 2, 3 to the right, which again, mathematically, 6 minus a -3, that becomes plus. So we're at 9, and there's my directrix. And then for the lattice rectum endpoints, I go to my focus, this guy right here, that's 3, 2, and I'm going to go up and down 2 times the p-value. So that would be 6, right? So I'm going to go up and down 6, up and down 6, 2 times 3. So I'm going to go up 6 to 8, and then down 6 to -4. Those are my 2 points there. And then I just draw my curve in. Okay? So that's how you graph any parabola. Okay, if once you find the vertex and the p-value, it just kind of does itself. You know, it is a good idea to look at the formula and say, okay, what is it going up, down, left, or right? You know, what comes first? What's my a value? And that kind of narrows it down to the direction, and then everything else kind of falls in. Okay. So I've got a third example. I'm gonna have you pause the video here and try to do this on your own. Remember, write the vertex down, see which direction is it going. Is it going up, down, left, or right? Find your p-value, find your focus, directrix, and lattice rectum endpoint. So go ahead and pause the video, give that a shot. And I'm going to show you just the final answer here in about 10 seconds. Okay, so hopefully you found all the different attributes. Hopefully you saw it was y equals, so that means it's going up or down. And with that negative sign, that tells you it's going down. So your final answer, your parabola should be going down. And then here's all the different attributes. Okay, so my vertex, -4, 7. My p-value ended up just being -1 in this case. The focus, and again, since my p was -1, my focus came down 1 from the vertex. My directrix went up 1 from the vertex. And then the latus rectum endpoints, left and right 2 times 1, left and right 2 from the focus, and then put the curve in there. Okay, so your assignment on Classroom, I'm going to have, I've actually gotten 6 of these that are in the same kind of format, and the p-values all come out to be nice, clean numbers, and won't worry about, like graphing a half point or something like that. So the p-values are all nice whole numbers. Kind of keep that in mind as you go through. So I'm going to end with this screen again, the same one I had up there a little while ago. If you didn't write those guys down yet, remember, it really just kind of, it's almost common sense, right? So the focus always inside of the parabola, the directrix always outside, and the latus rectum is always going to be parallel to the directrix and that distance 2p away from the focus. Okay? Hope you found this helpful. Feel free to go back through the examples if you need to. If you have anybody else going through the Conic section stuff, feel free to share it with them. And you can certainly feel free to subscribe to the channel to get updates when I post some other videos during this distance learning time. I hope you and your family are well. Stay safe, stay healthy, stay inside, for heaven's sakes. And feel free to email me or find me on the Google Meet room if you need any additional help. Thanks very much for your time. Keep studying.